Hello everyone, in this video we're going to take a look at the ESp32 I2S matrix shield that should be available on my Tindy now. It is for this D1 mini style ESp32, so it is not for ESp8266 D1 minis. You can see that they are quite different in terms of size or whatever, so it needs to be for this ESp32 one. So the major difference between this board and the previous matrix boards that I sold is that it doesn't need a P out connector anymore. So you just need to plug it into the connector that the arrow is moving away from. There's an arrow on this PCB as well that matches up with that one. So you just slot it in, press it down, and away you go. So I've also removed the dip switches from the panel. They're replaced by just resistors at the bottom. The dip switches were to solve a particular problem with the default pins of PX matrix, especially for the ESp8266. I'm not 100% sure if it actually impacted any of the other boards, but this board doesn't suffer from that, so it's not needed. But for whatever reason, if you want to disconnect that, like if you don't want the E pin connected, just don't solder in that resistor. But there shouldn't be any harm with leaving them soldered in and connected all the time, even if your panels don't need it. Just one thing to be aware of when you're plugging in the panel as well is that this is the connector that comes with it, and it has the right amount of contacts for it. But it is possible to offset it, so that's correctly placed in now. You can see equal spacing between the two, but it is possible to put it in wrong. So you can see here it's fitting in within the connector, but you can see there's two pins exposed, so that would be placed in incorrectly and the shield would not work. So to finish the installation, just place it in to that connector where the arrow is moving away from, making sure to keep it centered. Push it in nice and securely. You then take the power cable that came with your display. If your display came with a power cable, you slot that in there. If there's two connectors, it doesn't matter which one you use. And then you take the spade terminals that come with it and just slot it into this green one here. So I should probably loosen that a little bit more. So that's that one in there. Just make sure to keep the black wire to ground, obviously. And then we will take the red wire and plug that into 5 volts. Obviously you would screw this up to make sure that they stay in secure. So that is it fully installed from a wiring point of view. So it's a little bit easier than the PX Matrix one because there's no ribbon cable between the two. So next I want to show what comes with the kit. So a kit will come like this in a bag. For more information on how to do basically the installation or any other information, you can scan this or go to that website. I'll probably be redirecting to a GitHub page. I'm trying that out. I think it will be a better solution for information like this. It'll be easier to edit and people can even suggest edits or put PRs or whatever if there's spelling mistakes or anything like that. So I'm going to try that out. So to not open up a kit, because I don't actually have that many at the moment, I'm going to just show using a physically identical previous version, but the wiring is a little bit different, but it won't matter for installation. So what comes in the kit is the following. So it comes with the PCB, obviously. It comes with the P-in connector, so that goes down there and will get inserted into the matrix panel. It comes with 3 1K resistors that can go in here. Normally intended to go on the bottom, but there's no reason why you couldn't put it on the top if you didn't want to, or if you wanted to. Then it comes with this terminal block here, and then it also comes with just some power components for the power supply basically. So it's the barrel jack connector, the capacitor, there's a 3-pin connector here, that's for the diode bypass. So basically what that's for is you can choose to power the matrix panel from the USB of the ESp32 if you want to, but that would not be normal operation for it, because these panels, depending on how many LEDs you put on, can draw quite a lot of current, like maybe 4 amps or so, and you obviously won't be able to draw that from here. So the idea behind this jumper pad is normally you would have the pins connected, these two bottom ones connected, and that will mean that the ESp32 will get powered from the barrel jack, so it'll get the 5 volts from the barrel jack, but because of this diode down here, it won't, when you plug in the micro USB, it won't try power the display. So if you're programming it and you don't have power plugged in here, it won't go ahead and start running your full screen white application and break your USB port, so that's probably a good thing. Yeah, so the other things that are available as add-ons for this board are, I guess the main thing would be you can get these ESp32 D1 mini style ones. I do recommend that you probably just buy these off AliExpress. They're much cheaper than I'll be able to provide them for, but if you do buy them off me, I have tested them with a blink sketch, and they will also come with a female header and a male header, so you can use it as a standoff like this if you like. I always like doing that because if I amn't using the matrix panel or whatever, I can lift up this board, use it for something else, or if the board ever broke, I'm not out a matrix panel either, I can just swap it in. So yeah, as I mentioned, I would recommend just getting these off AliExpress, but I guess delivery is quite long at the moment, so I have a small amount of stock of them. Another option you can get is these pin headers, again, to use them as kind of like that standoff or whatever. Most kits I've seen, or most ones of these I've seen, have actually come with 4 10p headers and actually no male ones, so I'll probably make male ones available too. So if you buy the ESp32 off me, you do not need to get these because you'll get everything you need in the kit. But yeah, if you need the female headers, yeah, you can add them to it. The other thing that you can get is those screw terminals. I think I talked about them already. They're not really needed in most scenarios. They do look pretty nice on the board. They're red and black, but yeah, in normal circumstances, you're probably going to power it off a barrel jack from here, so you probably don't need it. But if you're powering it from maybe a power supply or whatever, that might be useful. You can also use it to power the display as well. So say the Pixel purse doesn't have those cables that come with it, so maybe it might make more sense to power from there, or you could just solder wires directly from here to the Pixel purse. So yep, that's another option. Another thing that is newly released with this is a nunchuck adapter board. So you can see this on the panel already, or on the matrix shield already. So basically on a previous version I broke out the pins for an accelerometer, which I'll show in a second, and that's just an I2C device, and I thought it would be interesting to make a nunchuck adapter for it. So yeah, it's just a PCB that plugs into the same holes as the GY521 accelerometer, and then it also comes with these 3D prints to make it more stable. So the nunchuck is quite heavy, the connector of it. So I have one here. So like there's wiggle here, but that's just the nunchuck wiggling on the PCB. Like the PCB itself is not moving. So if you take off these adapters, there is movement on the PCB, and I didn't think that that was too great. So I designed up these little adapters. I've test fitted them all, so they should fit, no problems. Maybe they'll be a small bit tight, but it should just slot on without much problems. And there you go. So we have a nice solid connection again. So yeah, that is included if you add the nunchuck adapter. And then finally, the last thing is this accelerometer module. So the same kind of thing. I don't have the accelerometer module open at the moment, but yeah, both the add-ons for here come with this female adapter pin and the male headers as well. So you just solder it in there, and then your add-on slots in there. I don't currently have a spacer for the accelerometer at the moment. I don't think it's as needed as the nunchuck one, because you know it doesn't move in normal circumstances. It's just with the nunchuck there is a big wire coming out of it and it's quite heavy. You can solder both the accelerometer and the nunchuck adapter directly to the board if you want. For the nunchuck adapter, I really don't recommend it, because the nunchuck itself is quite big, the block connector of it. So if I show you here, so if you didn't have that centimeter or so of space, you can see that it wouldn't be big enough with that big blocky thing down the bottom. So yeah, I would definitely recommend for the nunchuck adapter putting in the female one as kind of a standoff or whatever. But the accelerometer would fit in fine. But you also need to just be careful with the displays, because where that connector is changes on all the different displays. So you just want to make sure that everything fits in okay, or whatever you need. Okay, so let's get soldering. As mentioned, you will get a black PCB, but I just don't want to waste a black PCB on this assembly video when I have one that is physically identical other than the pin connections. Basically, in this version, I was using custom pins, and I didn't think there was any advantage to that, so I went back to using, I moved to use the default pins of the recommended library, so there's less changes for you to make when you're doing this. So what I'll do is I'll start with this little bag first. I'll start with the two flat components, so the diode. Just make sure that the gray part of the diode matches up with the marking on the silk screen. So that little line there should match up with the gray part of the diode. So you can just slot that in. And then you get your resistor. You can put that in any way you like, but it goes into this R1 port. So I'll just bend them. And I'll start this off with a solder. So there is a pretty large ground pad on this, so you can see there's not a huge amount of traces on the back, so anything that's ground is quite big. So you might need to bump up the heat of your iron anytime you're soldering a ground pad, and there is a couple of ground pads here. So I'm just going to start soldering. I'm at 370 at the moment, but that'll be completely different based on whatever irons you have. So we'll just start and we will see how we get on. Okay, so that looks pretty decent to me. Yep, we'll stick with that. So I'll just clip off the legs now. Okay, so that's that started. I guess next we will do this connector here. This one can be quite difficult to solder in just to keep it straight or whatever. So I just try place it in, and then I'll solder one leg of it. So that's one leg done, and you can see it's not at all straight here. So now what I'll try to do is I'll hold it, but just make sure that the one you're soldering isn't the one you're holding, because you'll burn yourself. And kind of get underneath the board while I'm holding it and try straighten it up. And that doesn't look too bad. It's not perfect, but it's good enough, I would say. So now I'll just finish it off. And there we go. Okay, next we'll probably go with the barrel jack. Kind of similar story with this. It's easy to get the barrel jack a little bit crooked. So what I would do is I would solder one leg of it. I'm going to start with this edge one because that is not connected to anything else. So it's not, it's easy to solder. It's not the ground plane or anything. And same thing here. I'm just holding it down, keeping it straight-ish. And there we go. That looks pretty straight to me. So we can finish it off. Again, one of these is the ground plane, this inside one here. So this may require you to keep your iron on it a little bit longer, or maybe bump up the heat of the iron, but yeah. If you had the connectors here, this would probably be a good time to install them. They're about the same height as the other things that we just installed. Will I do them? Yeah, sure, why not? So again, I'd probably just start with the power ones, or the 5-volt ones, rather than the ground, because the ground is more difficult with the heat being wicked away. So just put in one, make sure that it's flat with the board, and then press it in if you need to, or just keep it pushed down when you're soldering it. Okay, that's those done now. I think the next tallest thing is this green connector. So you're just slotting that in. Same thing as before, do one of them, because there is a bit of bend in the legs, so just do the 5-volt one and make sure you're happy in terms of the placement of it. As I mentioned, there is a bit of bend in the legs, and especially when you've a tight screw, it will bend anyways, so you possibly won't be able to keep it too straight anyways, so it doesn't matter a huge amount, but yeah, try keep it as straight as possible. So there we go. So the header pins are definitely around the same height as this, maybe even smaller than some of the other ones, but I actually find it easier to leave these to last because I use my ESp32 almost as a jig to make sure that it fits in correctly. And when you're using the ESp32 as a jig, that's quite tall, so it's taller than everything else here, so we'll save them till last. Okay, so next is the capacitor. So you just want to make sure that your white marking here lines up with the white marking on the PCB, so you can see it there. So again, long leg should go into the plus hole, and then your white marking will line up. So maybe the capacitor isn't quite as tall as the green connector. So I'm just going to do one pad, same as before, then just push it in, make sure it's straight, away we go. And then same for this ground pad. Like all the other ones, this might need to be left a little bit to get a good flow going. If you've got flux, it would be a good time to use it too. I do have flux, I'm not 100% sure where it is. I have it here, so I'll just put a little bit of flux on it to help it flow. You'll get away without doing it, just leave the iron there, keep it a little bit hotter, and when you're soldering something like this that's difficult, more solder is your friend, so If you have excess bits, I just rub it up the leg if it's not coming off, and then just it'll get cut off when you cut it. But yeah, so that looks pretty decent, and I've husky fluff on my board, which is always the way in this house. So we'll just cut off those legs now. Okay. I think it's easier to do these now, so you don't have to worry about your iron touching off the plastic of the headers if you're putting them in. So I'll leave that up to you. If you're soldering the ESp32 directly, do not do it until you've installed these, because you just won't be able to install it, right? So make sure if you're installing the ESp32 directly, I'll just use a D1 to demonstrate. Like, you're not going to be able to solder these if you drop this in here. So yes, you definitely want to do this part next if you're installing it directly. It's not as big of a deal if you're using the pin headers, but yeah, I think it is easier to do it this way. So we'll do the resistors first. So again, it doesn't matter which way we put them. So yours will probably arrive pre-bent. You may need to make some adjustments for it to fit, but so it doesn't matter which ones go where. If for whatever reason you lose the resistors or one breaks or whatever, you can just solder wire between these. The resistor is just there for a little bit of protection, that if somebody configured an output or an input or something on a pin that they weren't meant to, or you know, that a display had connected directly to ground or something like that. Yeah, but it's just to provide a little bit of no direct connection to ground, but yeah, it doesn't really matter. Like in normal circumstances, like if you were just following the wiring diagram of the library, it would just be connected directly, so the resistors are just kind of optional. So these should solder no problem whatsoever, because they're just GPIO pins. Probably shouldn't have them quite as flat as that. They won't snip off quite as easily, but shouldn't be a big problem. I think I mentioned at the start that you could solder these on top here if you wanted to. Unlike D1 Mini, the ESp32 board doesn't have anything underneath it, so it shouldn't be a problem. Even the height of the male header, even if you went directly in, would probably be enough to cover that. But yeah, I don't think it needs to be up on the top, so I'll just get it out of the way and put it down the bottom, was my thinking behind that. And then you also have your P-in connector. So like all the other things, I'm just going to do one. Make sure that it is straight. Looks pretty decent to me, and I'll finish it off. Just be careful when you're soldering these, especially the internally, or the pins quite close to this end, that it's easy to kind of forget what you're doing and burn the barrel jack or whatever. So just keep an eye on where you're putting stuff. So some of them are ground pads as well, so that'll be relatively more difficult. Like this one in the corner here is a ground pad. So same as before, just you might need to leave your iron there for a little bit longer. There we go. And there we go. Right, so to do the header pins now, take out this kit. I'm going to take out my ESp32 from the shield I was showing earlier. And I'm just going to put the female headers directly on the male headers here. Just push them down fully. There we go. So you just, well, I guess it doesn't really matter at this stage, but when you're installing it, make sure the USB lines up with this side. So you just slot it in there like that. And there you go. It should be fairly perfectly aligned. Just again, as always, start with one, make sure you're happy with it, and then you can finish it off. And there we go. There's our assembled version of the board, and it's looking pretty nice. So if we wanted to do the nunchuck adapter, I will just use an 8P header. So I recommend for soldering up both the nunchuck adapter and the accelerometer module, just place the male header in into a breadboard, then put it on top. Follow the same rules that we were doing all along. Just solder one, make sure you're happy with it being straight, and then finish off the rest of them. That will give you a fairly straight header on it. And then we can do the same thing that we've been doing before with this if we want to. We could actually use the separators to help us install this here. Just make sure you don't touch the separators with the soldering iron, because they're just PLA. They won't survive the heat of it. But that will give us a fairly straight connection on it. Like always, we can just do one or two. That will keep it straight, and we can move away from these now. And then we can finish it off. So it's not perfectly straight, it's a little bit leaning back, but good enough, I would say. But so it's always much harder to make adjustments if you solder more than one. Now it seems to be a little bit forward, but it'll be fine. I can hear people calling me, so I'm running out of time. Mommy's out in the garden, Sive. You're hungry? Okay, I'll help you in a second. Yeah. Okay, I'll get you a banana. Okay, so that is that soldered in. I should have kept it with the way it was leaning from the connectors, but it should be okay either way. Yeah, it still slots in fine. So yeah, just keep these on for support and just keep them kind of towards the edge so the nunchuck has enough room to go in. And there we go. That is a fully assembled board. Took about 25 minutes or so. Probably would be quicker if I wasn't recording it or whatever, but yeah. So hopefully that gets you going. And if you have any questions, feel free to ask in this video or ask on the Discord, or if you've any issues or whatever, you can contact me through Tindy. Okay, thanks a lot, and I'll talk to you again. Bye bye.